This is a video relating to running analysis of covariance in SPSS. My name is Scott Snyder, and the data set that we're going to be working from involves child development information. The dependent variables that we're going to be using will be PPVT, which stands for the Peabody Picture Vocabulary Test. We have longitudinal data on the PPVT from kindergarten to first grade to second grade and to third grade. For the ANCOVA that we are going to be focusing this discussion on, we are only going to be interested in the kindergarten and the first grade Peabody Picture Vocabulary Test results. The Peabody Picture Vocabulary Test is a measure of vocabulary competence, receptive vocabulary in children. We are using Roche-Wright scores, so these are scaled scores. So what we should see with scaled scores is that they will increase across time. So as we go from kindergarten to first to second to third grade, we would expect that these scores for individuals and mean scores will increase across time. Our independent variable is going to be family risk, which is an index of the level of psychosocial risk that exists within various families. It's on a scale. The scale that we are going to be using is on a scale of 1 to 4. So the primary question that we're going to be asking is whether or not first grade PPVT scores vary by level of family risk after statistically controlling for differences in vocabulary scores in kindergarten. So we're going to do two things. The first thing that we're going to do is we're going to test for homogeneity of regression, which is one of the assumptions of analysis of covariance, and it's a very important assumption for us to establish as being met before we proceed with the ANCOVA, because the consequences of violating it can be fairly significant. So it's something that we should always conduct, and it's something that we should always make sure that we see within articles that use ANCOVA. This particular study involved random assignment of classrooms to condition. We tend to find situations in which when we have random assignment to condition that typically homogeneity of regression is met, and the likelihood of meeting that assumption gets more challenging when we don't have random assignment to condition. So to do this, we're going to go to Analyze, General Linear Model, Univariate. Our dependent variable is the first grade Peabody Picture Vocabulary Test. Our independent variable is going to be family risk, and our covariate is the PPVT score in kindergarten. The first thing that we need to do is click on Model, and we need to run Custom, because this custom analysis is what allows us to test for the effects of homogeneity of regression assumption. So what you need to do is you need to send family risk over here, you need to send the PPVT over here, and you also have to create this interaction term, which you do by blocking on both of these variables using your cursor and the shift key, and then sending it over. Okay, the term is already there. Then you click continue. Now I have this actually set up to run other analyses, which we are not really concerned about at this point, so I'm going to remove these other options. Because all we're interested in initially is that test for homogeneity of regression. And here's the test right here. It's family risk by PPVT. The null hypothesis is that we have homogeneity of regression. That is, the assumption is that the effects of the covariate on the dependent variable are the same for every level of the factor or the independent variable. We do not want to reject that, okay? So we want to fail to reject that, and indeed, in this case, we failed to reject homogeneity of regression. So we have met that assumption, and we are safe to proceed with the ANCOVA. And again, we would typically want to test all of the various assumptions, but I wanted to make sure that you saw how to test the homogeneity of regression assumption, since its impact on the resulting ANCOVA is substantial. And we go back to analyze, go back to the general linear model, back to univariate. We leave the structure of our analysis the same, but we now go to model, and instead of clicking on custom, we're going to click over to the full factorial. Okay, this is the actual analysis that will run the ANCOVA instead of the test of homogeneity of regression. We still keep type 3 sums of squares, and we click continue. We go to contrast, because if there is a significant difference for family risk, we want to find out what it is. So make sure that you click on simple contrast. Make sure that you have identified that you've clicked this change to make sure that simple is indicated here, because if you don't do that, it won't run the traditional contrast. So we click continue here. We're going to go to options. We definitely want descriptive statistics, estimates of effect size, and homogeneity tests, and I recommend that we run the main effects analysis for our independent variable. So make sure you send family risk over. You have different choices here, including the Bonferroni. I think that we're fine using the least significant differences. Click continue, and we're going to click OK. So now we will have our data. We'll see, part of what I want to show you initially is that if we look at what these means look like here, so what we see is that for the first grade vocabulary scores, those vocabulary scores tend to be higher when there's little risk within the family. As the risk increases, we see that those vocabulary scores tend to decrease a little bit. We're going to come back and look at these means to see what kind of adjustment the covariate has made. We see that the homogeneity of variance assumption has been met as well. Here is the actual ANCOVA table. So what we see is that we have a main effect. So we find that the covariate is significant. So the impact of the covariate was statistically significant. If our alpha level was 0.05, we find a significant effect due to family risk. So this is telling us that after adjustment for the covariate, family risk had a significant impact on first grade PPVT scores. There were significant differences in PPVT first grade scores by level of family risk. However, when we look at the partial eta square, we see that family risk accounted for less than 1% of the total variance in PPVT first grade scores. But not surprisingly, kindergarten PPVT scores accounted for about 49% of the variability in first grade scores. So this data set, so these numbers, we have a lot of subjects in this particular study. We have a lot of subjects. So there's an argument to be made that maybe we should be using an alpha level of 0.01, which in this case would suggest that family risk does not have a significant impact on first grade PPVT scores after adjusting for kindergarten scores. So the issue of which alpha level to use to test your hypothesis is important. And when we see a situation here in which the eta square is very low, right, less than 1%, but it is statistically significant if we use 0.05, this is probably a function of the sample size, and we might want to reconsider whether or not we should use 0.05 or 0.01. That's a decision we would typically want to have made prior to running the analyses, but I wanted to highlight how for any analysis, ANCOVA, ANOVA, or otherwise, the significance level should be interpreted not just with the assumption that it's always going to be 0.05, but when we have over 1,500 subjects, as we do in this case, we might want to be using a 0.01 or even lower alpha level. We come down to, we look at our contrasts. So these are, we have various levels of risk, and this is going to be comparing those levels of risk, and we're going to be looking for the significance levels. And again, when it's less than 0.05, we could argue that there's a significant difference here. So between level 1 and level 5 risk, that is significant. But here for level 2 versus level 5, it was not significant. Not significant between level 3 and level 5. Not significant between level 4 and level 5. So if there is a statistically significant difference there, it appears to be between those individuals that have the least amount of risk and those that have the greatest amount of risk. So these are the marginal means after adjustment for the covariate. So part of what I want you to see is when we start looking at these means, right, we see that there's somewhat of a change in these PPVT scores based on the adjustment. So we see that group 1, that had 0 risk, still has the largest mean, but when we compare it to the mean up here, right, so it went from 96.985 down to 93.36. So there was a significant drop. When we look at level 4, level 4 went from 87.2 up to a 90.7 essentially. So it changed in the opposite direction. So when we adjust for the covariate, what you see happening here is that there's kind of a tightening or a shrinkage of variability amongst these group means. So the significant difference that we observed from the contrast was really between this one, this 93.361, and this 90.681. This is level 1 versus level 5. Pairwise comparisons are provided, and what we'll see is that these results look somewhat like the results that we just saw. However, this was not, and this adjustment here, this 1.605. I want you to understand that this is the difference between 0 and 1 with these estimates, right? So 91.75, 93.36, that difference is 1.6. Okay, so these adjustments, these comparisons are based on the marginal means, these adjusted means. I think that that's really basically what I wanted to highlight for you today.